Today we are going to talk about a property called acid. Why it is important to talk about, right? That's the most important question to answer. What if I do not talk about this and start using the databases? What will happen? The core is whatever we write. It may not work according to your thought process. It is not guaranteed that the way you may think that it should work, it may not work that way. Hence, this is most important to talk about. Whoever is writing any SQL query, it is important to understand, build the intuition, what exactly this property is called. How can we tune according to our need? How can we tune according to the product for which we are developing? So, all interrelated. Hence, knowing this is most important. Okay, a database is not built for a single user. If it is a built for a single user, and we really no need to talk about this. Hence, the database is not built for single user. There will be multiple users talking to the database. Hence, it has to provide a concurrency step. Since concurrency is there, what if somebody is trying to change a same row multiple people? Okay, how our database should react. Okay, we should know that. Otherwise, it will be very difficult to build a most strong, consistent system. Hence, it is important to talk about it. Since these are the basic fundamental problem, and this acid property addresses this. Okay, A for atomicity. C for consistency. I for isolation. D for durability. So durability is like, it is directly related to the persistent of. Suppose if I write something, it has to return to a disk so that if machine restarts, I could able to see it. That's persistent. Very simple words. Okay. Let's talk about what is atomicity. Before even we talk about atomicity, let's talk about the problem. Whenever we build any product, take an example, the banking product. The fundamental action any banking services provide, any banking, if you take any banking services, the fundamental services are bank money transfer, right? So A transfers money to B. Okay, this is called one action, or this is one product use case. This is what finally they go and tell to end user, that you can transfer money from A to B, and I make sure that the balance will never go to negative. Okay, that guarantee they have to give. But internally, software developers know that transferring money from A to B is not just only one action internally, it is a multiple actions. So if you write down the steps, one is read A's balance. Second, check A's balance. Third, update A's balance. Suppose if the money which you have to transfer is enough, and if you have that balance, then you do update A's balance. The fourth one is update the B's account with a new credit, right? So So once we say all these are success, only then we call the money transfer is completed. Otherwise, we will have to revert. For example, like while updating base account, for some reason it is failed, then we should revert this. So we should revert these things because it's read and we have to revert this too. Otherwise, the system is not consistent. All right. So this property is called atomicity. Either if you put multiple SIP or multiple SQL statement in a logical grouping called transaction, and all should succeed or all should fail. This database guarantees this, whichever database guarantees this, and they say this database provide atomicity. Okay, we spoke about two things. One is durability, second one is atomicity. The remaining other two is nothing but in ACID. We spoke about this, we spoke about this. So the remaining two things are consistency and isolation. So consistency and isolation cannot be discussed independently. The reason is like it is interrelated. A consistency is a tunable parameter. So which is used to tune? A property called isolation. For example, consistency can be put it into a meter where weak to strong, and we have four parameters here. These four parameters called isolation level. First is read uncommitted, read committed. This is repeatable read, and fourth one is serializable. So according to what you choose, that level of consistency the data system is going to provide. That's why I say like this is called consistency and this is called isolation level. That's why we cannot discuss this in two different items. So isolation is used to tune consistency level. So then we'll have to talk about what is read uncommitted, read committed, repeatable read, and serializable. Serializable is something you can consider that a database executes each and every query the way in which it comes. It doesn't give any concurrency. So since it is not giving any concurrency support, the database will become slow. But it guarantees that strong consistency because when someone is doing something and it doesn't allow anybody to modify any data, hence it guarantees strong consistency. But the remaining three, it's again tunable parameter. Like what level we'll talk about it. So serial, when you run any transaction, and if you mark this transaction as serializable, when this is executing, it will never allow any other transaction to modify the data which is currently playing around. So that way it gives very, very strong consistency. Let's talk about the remaining three. One is read uncommitted. Consider we have a transaction 1 and transaction 2. Okay. Suppose when this transaction started at t1 time, and this is also t1 time, okay, and I read from a table 1 a value a, okay, and after some time what this guy has done is this guy immediately updates the same table value a. Earlier it was 10, now it is updated to 200. In the same transaction, if I read the same table and data A, if it gives 100, this is called dirty read. Okay, and this is bad because within the transaction, first time it gave 10, second time it gave 100 because this guy has changed A value, and it is not even committed yet in this transaction, but it is just changed and is, but it is not like confirmed, but still the database like shows that change to other transaction, which is called read uncommitted isolation level, which introduces something called dirty read. This is very weak consistency. Okay, so whenever any database has this isolation level as a default configuration, then this is something which you can experience. Hence, when you build a product, banking sector product and all, this level of isolation is not at all recommended, not even for any product. Okay, we should not even use this. That's why whenever you are writing any query, looking at the ACID properties is more important, because it's going to tell you like whether the query whatever you are going to write is going to work when multiple people are trying to change the same data or not. The second one is read committed. The only difference is we have transaction 1, transaction 2. Okay, suppose I read table 1 value A, and here I modified table 1 value A. Okay, but consider I haven't committed here. Hence, I haven't committed. If I read the value A again after like this transaction to change the data, it will give only 10. Here it may change to 100, but this won't come here. Only if it is committed, it will reflect in other transaction. Hence, this is guaranteed that when you keep the isolation level as read committed, the database system guarantees that only committed values are visible to other transactions. Okay. If it is just modified but it not committed, then it will not be visible to other transactions. That guarantee it gives, that level of isolation is called read committed. The problem here is repeatable read. Suppose if it is committed, and here it will be 100. So then when I run any transaction, if I'm reading a value across this transaction, it is important that it should remain as it is. Whatsoever happens outside of this transaction, right? That's most important. If you need that level of isolation, that's where like it comes repeatable reading. If you read value A in a transaction 1, okay, whenever you read, it will always give you the same value. So this is achieved something called snapshot in the database based on the filter query whatever we passed. So this is something great. I mean, it solves most of the problem other than a problem called phantom rates. What does this mean by? So this won't bring any rows which are updated. But suppose somebody deleted or someone has inserted, deleted into these two becomes unavoidable. So to kind of avoid this phantom rates, that's where like the serializable comes into play. When you configure your system to serializable, even phantom rate can go off. So this is what ACID properties are called. Thank you. Thanks for watching. We'll again connect in some other discussions. Thanks for watching. Bye.